Understand that you can take a tag that would have been working for 6 months, as you just said, when you've lost your camera, when you've lost whatever it was that it's tagged. The moment, if it runs out, the moment that you want it to work, you need that battery to absolutely be working.
That's right.
Right, so that's the second phase of the evolution. Now let's move on to see how that then plays its part when we start getting into bigger systems that involve matter.
So, this is another video coming at you from CES with Guy and Nick from Atmosic. So ipXchange talked with Atmosic back at Embedded World. So this is quite a different one because instead of mainly focusing on their energy harvesting Bluetooth SoCs, Guy and Nick actually go on a journey through all these different remote controls that Atmosic have helped develop with their technology, which don't require batteries because of the energy harvesting. And then we get into a really cool discussion about Atmosic's new devices, the ATM34 series, which introduce stuff like Matter and Thread and Zigbee. So yeah, this is a great one. Enjoy it.
Hello, welcome IPX. We are here yet again at CES and we're going to talk to Nick from Atmosic.
How you doing, Guy?
Very well. Good. So, we're going to talk about energy harvesting, but what we're going to do is we're going to go through a little evolutionary journey about how energy harvesting has gone from these, how it's evolved, and Nick's going to explain how that's changed, and then how that then challenges the whole concept of battery management moving forward in a whole process of things like intelligent building and information protocols, so you can extend battery life. So we're going to start with where energy harvesting started and how that's evolved, and then we're going to move on as how that technology has evolved and turned into turning battery life to maybe 3-4 times longer in intelligent sensors.
Sure, okay.
Over to you.
You want to do this with remote controls?
I think that's a good place to start because that's where it all started.
Well, certainly for our company, we've done a lot in the remote control space. You know, the interesting thing about remote controls is people have originally started with big, heavy AA batteries.
Yep.
We've moved into coin cell batteries. We've added PV cells, which most people refer to as solar cells.
Yes.
The problem with solar cells has always been that the small glass window that was typically on those calculators you remember from school. They really don't.
You've just aged me, but yeah. Okay, all right, okay.
They really don't meet the ID requirements of some of the newer companies and what they're looking for.
Yes, and they're not beautiful.
They're not. But where that technology has gone to is now they have the dye sensitized one, so that you can make the PV cell itself look like the plastic of the remote control,
yep,
as opposed to a window.
Can you give an example of that?
We can. There's a couple just here, and I'm assuming we will.
Yeah, we could. We'll
look
yep,
shortly.
Yep.
So if you look down at the front here, this is our reference design. You can see more of the traditional PV cell, which has got that window type product. As you move further down, you can see some of the other implementations by our customers here, where the window has completely disappeared,
yep,
and the black plastic actually also matches the PV cell.
Yep.
A slightly different one just up here, so that you can actually see it. We've kind of subtly mismatched the black, so that it's
so you can see that.
So we can see it and demonstrate.
Yeah. Just carrying on the conversation, we sort of see established energy harvesting applications. So just show us the evolution as how this has gone from
PV cells. Yeah.
Cells.
Solar, which is what most.
Solar. I was going to call it solar. I was thinking that wasn't going to
PV. Photovoltaic.
Yeah, that wasn't going to make me sound very intelligent, but we'll go with solar.
Yep.
Solar panel on the front there,
yep,
and then you've made that more elegant. So just talk us through.
Well, we haven't. Our partners have, right?
Yep.
So we don't manufacture PV cells.
No. Yeah.
But what they have done has enabled things to get a lot cleaner. So when you look at these other remote controls, you can see that the whole cell is lost into the idea of the product, which is much more appealing to those guys that are trying to make products. They don't want that glass that you see on the calculator.
Yes.
But fundamentally, in order for us to play our part, it's all about making the efficiency better.
Yes.
So we operate in a much lower power area, if you will, than a lot of our competitors.
Yes, but making that elegant, still your efficiency makes them make that more elegant.
Correct.
The more efficient you are, the more elegant they can make that look.
Correct. And then as we move further down the table, you can also see things like tags have taken off.
So let's...
Sure.
We
I'll go to this side.
started the video talking about this is going to be an evolution.
Yep.
Let's move on.
Certainly. So in the case of tags, what you've got here is a product that needed low power. If you've got a tag that only lasts 6 months, it has a flat battery when it's needed.
Yeah.
Right?
When you've lost it.
When you've lost the thing,
Yeah.
right?
Yeah.
So what you have is here you start seeing products where that life has been extended substantially. So what might have been 5 months of a battery life in the earlier iterations of tags, now it's using the Atmosic chipset, and we have that low power capability.
Yeah, all coming from there, remember?
You typically see 2 years, you see 5 years, those kind of numbers in tags.
Yeah.
Now, those tags might also have ultra-wideband. There might be a lot of radios in these products which are, altogether sum up to a power-hungry device.
Yeah.
So us being able to operate at that much lower thing, much better battery life.
Yeah.
Long term.
So just as a reminder, we go from energy harvesting, saying how do we power devices, to saying how do we make batteries more efficient and last longer, and keep doing their job.
That's right, because that also carries to a good sustainability discussion as well.
Yeah.
It's a lot greener.
Less
if you have
batteries.
Less batteries.
Less batteries is good for the world.
That's right.
Okay.
That's right.
So we understand that you can take a tag that would have been working for 6 months, as you just said, when you've lost your camera, when you've lost whatever it was that it's tagged. The moment, if it runs out, the moment that you want it to work, you need that battery to absolutely be working.
That's right.
Right. So that's the second phase of the evolution. Now let's move on to see how that then plays its part when we start getting into bigger systems that involve Matter.
Yes. So Matter is another great normalizer in the semiconductor industry. People are trying to implement Matter. A lot of Matter products would be plugged in. You'd have light switches, plug sockets.
We have a wire.
Yeah, well, that's really just for the sake of the demo, but you're right.
Yeah,
in real life,
if this was a building,
you don't want those wire pulls. They're expensive.
Yeah.
We discussed that earlier, but also it brings less flexibility on what kind of products you can have. Light switches, we know there's going to be wires in the walls. We know there's going to be lights in the room. But what about occupancy sensors?
Yeah.
Right?
Yeah.
We can put an occupancy sensor in a room. It might want to be talking about multiple lighting systems. You might be putting different lights into a room, and you want different scenarios to be there taken care of. You don't want to be changing that battery in the occupancy sensor every 5 minutes or every 5 months.
No.
IT would hate you.
Yeah.
So in this case, you've got a better position for battery power for that smart home.
Absolutely,
space.
yeah. So just from our IPX community's point of view, let's just go through this journey again, which is energy harvesting. This works without batteries. It's harvesting the energy from solar. So then you take the working experience to do that, to put it into a tag, so that the battery goes from lasting 6 months to 18 months, just using the things that were learnt here and putting them into a tag. Then what happens is you then start going into smart buildings, which is systems, where you've got a system going on, and it has to take in information from sensors, whatever they are. Just give some examples of the sensors that you might
Occupancy sensors, leak sensors, glass break sensors.
Yep, everything.
Glass break sensors is interesting because it also lends itself to the PV cell, because you're on a window. You can harvest light.
Very good. Very good. So all of a sudden, you're talking about discrete sensors in a system, but they all have to be communicating with the system. And again, what you don't want to be doing is having those batteries run out after 6 months. You want them to be sitting there doing their job, sending the information into the system and understanding the system so that you're not replacing those batteries. That is essentially what you are doing.
Correct. And we're also doing it with the 802.15.4 protocol, which is good for home automation. It's a very lightweight thing. It's IP based. It's self-healing. Unlike Wi-Fi, if the router goes out on Wi-Fi, everything's gone.
Yeah.
This will find its way to its destination through the other nodes.
So he's got a really, really good graphic here that will explain that. So why don't you just explain what's going on.
Actually, that's not the one I would show you.
So we'll pause there.
This is the one I would show you.
Yeah, Nick's got this really good graphic that will explain to you how some of the protocols work.
That's right.
Excellent.
So fundamentally, what you've got here, and I'm sure after the fact you can stick this graphic in your
We will.
in your thing. But basically, on this thread side here, you can see that there are lots of devices. All of those devices will pass them the message on.
Yeah.
So if this device was mobile and walked away from the network, the message would change its routing through the bottom here, as opposed to going up over the top potentially.
Yeah.
In Wi-Fi, if that router disappears, it's all disappeared.
Yeah.
Right? But because it's all IP based,
Yeah.
I can get my message from here all the way through the thread network, through the Wi-Fi network, potentially through Ethernet, DSL, cable, cellular. Keep going with that list
Yeah.
to get to here,
Yeah.
which is why on my watch I can get messages that things happened. On the TVs I can get messages that things happened, and so forth.
Yeah. So the point being here is that I think that when you would have been thinking about remote discrete sensors, you wouldn't have been taking into account that technology is now caught up using thread and what was the other thing you were talking about?
The Wi-Fi side?
Yeah, the thread and matter.
Yeah.
Yeah. So now these systems which are wired, you can be very secure in the fact that the sensors will still get their information to where they need to get to, which you wouldn't have considered maybe even 12 months ago.
Correct. Yeah. Well, I mean, obviously, in the industry, we've been working on this for some time, but publicly,
Yeah.
it's really all starting to happen right now.
Yeah, absolutely.
Yeah.
So in the past, you'd have expected your sensors, if you were using sensors, you'd expect them, one, you're going to have a problem with the battery, so you maybe be putting more batteries, which is environmentally very poor, with high maintenance. Now what you're saying is you can put your sensors, whatever those sensors are you're discussing, they're going to fit in with the system, they're going to keep sending the information in because of the way that you've made that battery life so much more efficient.
Correct. And there are other challenges which are placed here. As we've moved into the modern world and as we're using the internet to get our messages from A to B, security is also key. Security, of course, uses more power because of the encryption,
Because
decryption, and so
the
forth.
amount of code that it's running.
And there's the picture that you were bringing up earlier. You can see here, as you go through the network, you're going through thread, you're going through Ethernet, going through Wi-Fi. Each one of those has got their own little encryption thing. But Matter brings this secure tunnel all the way through from
Yeah.
A to B.
Yes.
Yeah?
Yes.
So you actually have double encryption, or double
Yes.
security rather, and Matter is all the way through.
Yes. So again, so I mean, at the end of the day, what this all comes down to is everything is getting more complicated. Everything is getting more connected. At the end of the day, you're in the world of a sensor sending that information through the system,
Correct.
which is either complicated with Matter and it's got to find different ways of getting through the system, or adding layers of security, which is going to burn energy again.
Correct.
Which is going to make, again...
Which makes our approach even more appealing.
Exactly.
That's right.
Exactly.
Yeah.
So it's all about, at the end of the day, what's going on here is when you've got sensors, you know that they're going to have to stay on and be ready to be used, like the tag. The sensor's got to be able to do its job, and the system is going to be drawing more power because it's doing more things over and over and over again. So you need the most efficient, elegant way of expanding and lengthening that battery life, and that's what Atmosic are showing us at CES today.
And I have one extra advantage for
I
our
thought we'd
customers.
finished.
Yeah, no, we have not finished.
No,
never.
we've not finished.
So, what's also nice about our solution, our previous customers that might have used the ATM33, for example, which we introduced to you last year at Embedded World,
Yeah.
we've made this solution pin-for-pin compatible to that.
Right.
So if they've got Bluetooth sensors and they want to add 15.4 to that,
You can
it's a
retrofit.
pure chip change.
Yeah.
Yeah.
Yeah. Very good. Very good. Okay. Thank you very much. That's a really good and interesting innovation. How our community can understand how to extend their battery life in very complicated systems.
That's
Thank
right.
you.
Cheers.
Good. Whoops.
Oh, wrecking the place.
Yeah.
I really hope you enjoyed that interview between Guy and Nick. I've done a write-up of the new ATM34 devices. It's kind of at the stage where Atmosic are only releasing the full specifications to potential customers. So yeah, head to the ipXchange website if you want to register your interest in this new device. But we've also got a full write-up on the ATM33 series if you want to get a little glimpse of that energy harvesting and Bluetooth SoC. Keep designing.
Hey, where my engineers at?